Hello all, welcome to the new topic Congruences of Number Theory. Congruences is actually one of the most remarkable relations in number theory. Actually, this relation was introduced and developed by Carl Friedrich Gauss, and who is known as the Prince of Mathematics. And he has given a detailed study in his famous book, which was written when he was only 24. Okay. So we will move to the also the simple was also developed by Gauss, which is most famous, most equivalent similar as the equality sign. Now the congruence modulo M. First of all, we will define what is when two numbers are said to be congruent modulo m. Let m be a positive integer, then an integer a is congruent to an integer b modulo m if m divides a minus b. Okay, m be a positive integer. We say that an integer a is congruent to an integer b modulo m if m divides a minus b. We write this in symbols as a congruent sign, that means the equality similar to equality congruent to b modulo m. M is the modulus of the congruence relation. Okay. If A is not congruent to, if A is not congruent to B under modulo M, then we say that A is incongruent to B modulo M. A is incongruent to B modulo M. Okay. And we symbolically we write this as A incongruent to B modulo M. Now let's look at some examples. 5 divides 20, that is 23 minus 3. 5 divides 23 minus 3, hence so 23 is congruent to 3 modulo 5. 3 mod 5. Similarly, 6 divides 48 minus 12. 48 minus 12 is that is 36. Okay, so 48 is um, 48 is congruent to 12 modulo 6. Also, 16 also 16 divides uh, 16 divides 32 or 32, or we can say that 28 minus 4. 16 divides 28 minus 4. This implies 28 is congruent to minus 4 modulo 16. Also, we know that 20 is not incongruent to 3 modulo 4, since 20 is incongruent to 3 modulo 4, since 4 does not divide 20 minus 3. 4 does not divide 20 minus 3. What is 20 minus 3? That is 17. So since 4 does not divide 17, we can say that 20 is incongruent to 3 mod 4. Now we move to one theorem which gives an important relation or important definition for congruences. Actually, this congruence, this is a relation between the congruence and equality. A congruent to B modulo M if and only if A is equal to B plus Km for some integer K. Okay. First of all, we have to assume that A congruent to one part, that is, suppose A congruent to B modulo M. Then by the definition, therefore by the definition, and by definition M divides A minus B. M divides A minus B. Then mm, A minus B is equal to some K into M. This implies A is equal to um, B plus K into M for some K for some integer K. So we have proved the one part. Now conversely assume that A is equal to B plus K into M for some integer K. Then A minus B is equal to Km, and so M divides A minus B, and consequently A is congruent to B modulo M. A congruent to B modulo M. So the result is very relevant. A congruent to B mod M if and only if A is equal to B plus Km for some integer K. So one important observation. If B is equal to 0, we can say that A congruent to 0 mod M if and only if A is equal to some K into M, if and only if A is equal to 0 plus Km or is equal to A, which implies A is equal to K into M. So A is congruent to 0 modulo M. A congruent, an integer is congruent to 0 if and only if it is divisible by M. So A is equal to K into M. Okay. And then, for example, we can say that 23 is congruent to 3 modulo 5 and 23 is equal to 3 plus 4 into 5. Now this is a useful information.